only increasing between the domain of from 0 degree and 90 degree. So that means you have a smaller angle for theta 1 and bigger angles for theta 2. Oh, theta 2. Theta 1. So big N, small N, big N1, small N2, small sine theta 1, big sine theta 2. That's what we have. That's the refraction. Cool. Number 2. We keep on increasing the angle until the point the theta 2 is almost 90 degree, and when it's go over 90 degree, almost all the light is being reflected. So in the diagram, it's just look like this. And remember, as I emphasized before, and I'm pretty sure who listened carefully about the video or what I talked about at the beginning of the lab, you benefit from the quiz. This total internal reflection only happens in higher index, in the region of higher index of refraction. Why I emphasize that? Because I get points off when I'm doing that optics class back in undergrad. It's painful. So you said theta 2, that's 90 degree, right? It's the critical angle. Like once the angle go beyond that, almost all the light is reflected. So sine theta 2 obviously is 1. So the theta 1 will be critical angle. Then we have sine theta critical equal to N2 minus over N1. For most of the case, we do the refraction. The N2 is air, right? So here is our ceramic, and then here is the air, and then it's reflected this way within the ceramic. So that means N2 is 1. Then we have sine theta is 1 over N2, 1. There we go. That's the total internal reflection. I think that's everything you need to know for lab 7, which is not a lot, but it's quite useful in real life. And for instance, you want to spear the fish, you need to know it's not exactly where it is. If you want to jump into a pool, thinking that you won't drown because it looks really shallow, it's actually not, because it's refracted, so it looks shallow, and actually it's not. Okay, let's go to lab 8. Oh, by the way, any questions? Lab 7? Okay, cool. Lab 8 is length. There's only 2 formulas that we need. Is length law and magnification. So length law, lab 8. Hopefully you can make it. That's 1 over P plus 1 over Q equals to 1 over F. I think P is object distance. and Q is image distance. Great, thanks. Image distance. And F is to pay respect. Is focal length. Anyway, so the ray diagram, boy, will be look like this for the scenario that is p greater than f focal length. That is p. Object distance. Remember how to draw the ray diagram. Parallel, and go through focal length, and then go through the center of the lens, like a straight line. And don't forget the arrow, and here is our image. That will be our image distance, Q. And that's our focal length. And there's two more scenarios. P less than F. So here is F. P less than F. Parallel. Go through focal length, focal point, go straight through. There's still that will never intersect, so you need to trace back. That's our the point. That will be the imaginary virtual image. That's P, Q. That's F. So. And of course, there's a extreme case, p equals to infinity, which is my favorite. During summer when I'm a trouble kid, I just go to the ant colony and try to burn the focal length. Is all the light with a radius of that. Because you can essentially think effectively the sun is coming from infinity with respect to the scale length of the focal length. So yeah, almost all the light will go to one point, which is quite hot at that point. Yeah, but anyway, so you can see that for the real image, you can see the image is flipped for one lens system, and the virtual image is the same orientation as it is. To put into the perspective, we can introduce another concept: magnification. The height of image over the height of object. So you can see that is positive, that's negative, that's positive, that's positive. So even though on the